Hello everyone, my name is Vitaly Kazako, and today I would like to introduce the second module of the SP upstream trailing called drilling fluids. Mud drilling fluid circulation system is one of the most important systems used in drilling wells. This system has important function. Let's talk about it. First is the remove drilling cuttings from the borehole. Second is the release cuttings when preceded by surface equipment. Next is to prevent the borehole from collapsing or caving in. Clear, cool, and lubricate the drill bit and drill string. Protect producing formation from damage that could impair production. Help support part of weight of the drill string casing. Control subsurface pressures. Suspend cuttings and weight materials in the suspension when circulation is stopped. Control subsurface pressures, carry and release the cutting of the surface, and allow cuttings to settle up of the surface. Drilling fluid properties. Let's talk about gel strength. Gel strength refers to the ability of the drilling fluid to develop a gel as soon as it stops moving. Its purpose to be suspend the cuttings and move solids in the borehole and not permit them to settle around the bit when circulation is halted. Gel strength should be low enough to allow the cuttings to be removed on the surface, permit entrained gas to be removed at the surface, minimize swabbing when the pipe is pulling from the borehole, and permit starting of circulation without high pump pressure. And the second is the mud weight. Mud weight must be sufficient to contain subsurface pressure and to prevent the formation from caving in. Not practical or economical to have the mud weight is too high. The next drill fluid properties is the viscosity. Viscosity is the resistance to the flow. It affects the ability of the drilling fluid to lift the cuttings out of the borehole. It depends on the amount of character of suspended solids measured in the field using a Marshall funnel, and the measuring is of the seconds per quart. And the water loss is the control of the filtration rate is necessary for two reasons. A poor quality filter cake may cause excessive water loss and produce an excessively thick filter cake. High water loss can cause deep invasion of the formation, making it difficult to interpret wireline logs. Next is the pressure control terminology. There are four terms. It's the hydrostatic pressure, pressure gradient, equivalent mud weight, and pore pressure. Hydrostatic pressure is the pressure that exists due to the mud weight and vertical depth of the column of fluid. The size and shape of the fluid column has no effect. And on the slide, you can see the formula is used to calculate the hydrostatic pressure. Next is the pressure gradient. Pressure gradient is the rate of the changing of the hydrostatic pressure with depth for any given unit of fluid weight. Typical formation water density used is a 8.6 ppg, yielding a pressure gradient of 0.446 p per feet. Equivalent mud weight. The mud weight that would exert a hydrostatic pressure equal to the sum of the imposed pressure of the hydrostatic pressure. Use it interchangeable with equivalent circulation density and calculated by DLS computer using power law. Next is the pore pressure. Pore pressure is the pressure that is exerted by fluids contained in the pore space of the rock and is the strict meaning of what is generally referred as the formation pressure. So let's talk about type of drilling. There are four types usually used in drilling. Is the water-based mud, oil-based muds, synthetic muds, air, gas, and mist systems. Let's start with water-based muds. Water-based muds are divided by non-dispersed and dispersed muds. Non-dispersed include spud muds, natural muds, and other lightly fritted systems generally used for shallow wells or top hole drilling. Dispersed muds are often dispersed by deflocculants, filtrate reducers. Potassium containing chemicals are frequently used to provide greater shale inhibition. Water-based muds also divided to calcium fretted and polymers. Calcium-treated mud resists salt and anhydride contamination, but also susceptible to gelation and solidification at high temperature. Polymers, muds incorporating generally long-chain, high molecular weight polymers are utilized to either encapsulate real solids to prevent dispersion and coat shells for inhibition for increasing viscosity and reducing fluid loss. There are low solids and salt water system. Low solid system typically use polymer additive such as viscosifer or bentonite extender and are not dispersed. Saltwater muds are usually prepared from brackish seawater or producer water sources. Let's talk about components of water-based mud. There are inert solids, reactive solids, and continuous liquid phase of water in which clay materials are suspended. Water component, either fresh or saltwater. Saltwater commonly used in offshore drilling. Saturated saltwater is used for shale inhibition and drill thick evaporate sequence. Reactive solids is the clays, dispersions, or deflocculants. Clays is the basic material of the mud. Usually use bentonite, attapulgite, and natural formation clays that hydrate and ether the mud system. Dispersions reduce viscosity by adsorption onto clay particles, reducing flocculation. For example, is tannis, phosphates, lignite, and lignosulfonates. Flocculation. Flocculation is a thickening of the mud due to the attraction of clay platelets in the mud. The causes of flocculation is high active solids concentration, high electrolyte concentration, or high temperature, usually detected by abnormally high yield point or abnormally high yield range. Filtration control agents such as sodium carboxymethylcellulose control the amount of the water loss into permeable formation by ensuring the development of a film impermeable virtual cake. Detergents, emulsions, and lubrication assist in cooling and lubrication, also used as spotting fluid in order to free stuck pipe. Defoamers use it to prevent mud foaming at the surface in mud tanks or surface cleaning equipment. Sodium compass precipitate or suppress calcium or magnesium that decrease the yield of the clays, and calcium compounds inhibit formation clays and prevent them from the hydration or swelling. Inert solid component. Weight material finely ground high density minerals held in suspension to control mud density. Loss circulation material used to plug the loss circulation zone. If none of the LCM materials successfully plug into the loss circulation zone, the zone must be cemented off. Anti-friction material used to reduce torque and decrease the possibility of differential sticking. More frequently, it is used on the high angle direction wells where torque and differential sticking are a problem. Most frequently used materials are inert polyurethane spheres. Low solid mud system solids content is less than 10% by weight, and of the mud weight is less than 9.5 ppg. It may either have a water or oil base. Oil-based muds use it for a variety of applications where fluid stability and inhibition are necessary, such as high temperature wells, deep holes, and where sticking or hole stabilization are problems. There is a high cost and difficulty of running and complication of geological evaluation precludes their use on exploratory wells, other than in certain troublesome evaporate and clay sections. Emulsion system is oil in water or water in oil. Diesel or crude oil is dispersed in the continuous phase of water. Invert emulsion muds are water in oil emulsions, typically with calcium chloride brine as infused phase and oil as continuous phase. Oil muds. Oil-based muds contains blown asphalt and usually 1 to 5% water emulsified into a system with caustic soda or quick lime and organic acid. Synthetic mud. Synthetic fluids are designed to mirror oil-based mud performance without the environmental hazards. Primary types of synthetic fluid: esters, ethers, polyalpha olefins, and isometric alpha olefins. Air, mist, foam, or gas system. Used principally in hard clay or rock formation, or in areas where there are little formation water. All times a foaming agent is used to improve carrying capacity. Air drilling. Air drilling is a compressor assembly including cooling system, air receiver, and unloading system replace the mud pump. The air line is connected to the swivel hose at the top of the kelly or the top drive. The small stream of water is often introduced into air system to help cool the drill bit and control dust. That's all. Thank you for your attention.